So we already know how to find the area under one curve. So finding the area between two curves is very similar. So I just want to point out, like, let's say you have a square and a circle, and we want to find the area between the square and the circle. So we did this. This is a horrible picture, but you get the idea. You learned this in geometry. You find the area of the square and you subtract the area of the circle in order to find the area between them, right? So similarly, we are going to find the area under both of these functions and subtract in order to find the area between them. So here, let's say I want to find the area from A to B, where A and B are points of intersection. Okay, so it's where these two graphs cross. And sometimes you'll be given the points of intersection, and sometimes you have to find them. But again, that's an algebra, 1, 2 pre-calculus concept, finding points of intersection. But then I want to calculate this area here, and I'm just going to use some representative rectangles. All right, so let's take one of these rectangles, okay? So I'm just going to use just this representative rectangle. First of all, what is the width of this representative rectangle? And you know it is going to be dx. So the width of that rectangle is dx, and then how do I find the height? Well, the area under f of x goes all the way to the x-axis. Remember that the area under a curve goes all the way to the x-axis. But I want to subtract the area under g of x. So I want to get rid of this part right here, right? And then I'm left with just the area between f of x and g of x. So the way I set this up is I'm going to do the integral from a to b. The height of my representative rectangle is f of x minus g of x. Okay, because I'm taking f of x, which is the area all the way to the x-axis. I'm subtracting the area under g of x, and then I'm left with the area between them. And then the width of each representative rectangle is dx. Simple enough. It's the area under the function that is furthest away. Or actually not furthest away, above the not above the x-axis. I should say the upper function is a clearer way to say this. The upper function minus the lower function. Okay. So likewise, let's say we shift both of these functions down c units. And because I shifted both of them down c units, you should notice that this area is exactly the same as the area in the previous example. The only difference is now we're like partly above the x-axis and partly below the x-axis. But that's okay, because what if, again, this area is the same as the previous example. What if I shifted both of these graphs up C and then I subtracted them? Okay, well, if I shifted both of the graphs up C, I would just be left with f of x minus g of x again. So the point I'm trying to make with this example is it doesn't matter where the area is located, because you can always shift both graphs up or both graphs in whatever direction. And when you subtract them, you're going to get the same answer as you got before. So even if you have f of x minus c, the area from a to b of f of x minus c minus g of x minus c dx, the negative c's cancel. Okay, so my point is that if you shift your functions up or down, it makes no difference. Your area is still the same, so you are still going to do upper function minus lower function, whether they have shifts, whether they're crossing the x-axis, below the x-axis, it doesn't matter. It's always going to be upper minus lower. Upper function minus lower function, okay? All right, now let's do number 14. I recommend, just like I do for all of these problems, like try it yourself first and then only use the video to make sure that you understand it. But you learn a lot better by doing it yourself before you just sit and listen to me yammer on for 10 minutes. So here I have 3 functions. And we are just setting up, we're not going to solve, we know how to solve integrals at this point. I am setting up the integral or integrals to solve for this shaded region between 3 different functions. So I'm going to draw my representative rectangle. I've got this one. This is between f of x and h of x. And then I'm going to draw another one over here, and you'll notice that this one is between g of x and h of x. So I have different representative rectangles. I've got representative rectangles over here that are between g and h, and I've got representative rectangles here that are between f and h. So I'm going to set up two different integrals, okay? And so I'm going to start at, this looks like positive 1 until 2, 3, 4, 5. Just going to double check. 1, 2, 3, 4, 5. Yes. From 1 to 5, my upper function is f of x, and my lower function is h of x. Then, so that's my kind of orange area, I am going to add the area next to it. So now I've got the area from 6, 7, 8, 6 to 8 of upper function is g of x, lower function is h of x. Okay. I'm going to go ahead and just practice the algebra, even though I know you guys know how to do this, of finding what f and g are. So f is a line with a slope of 2 that passes through negative 4. You can use point slope form. 2 times x minus 1 minus 2 is the point slope form for f of x. Minus, and then h of x has a vertex. Just erase this, too much to look at. Has a vertex of 3, negative 4. So that's going to be some a value, x minus 3 squared minus 4. My a value, I'm going to figure out by plugging in a point. So I have 1, negative 2. So negative 2 is equal to a times 1 minus 3 squared minus 4. Add 4 to both sides. I get 2 is equal to a. 1 minus 3 is 2. 2 squared is 4. Divide, I get a is 1/2. Rewind the video, slow it down if you need to. But you should be able to solve for the equation of a parabola in vertex form. And then for my other one, the line is a slope of negative 1. So negative, and then I'm just going to use this point here. That's the point 8, 4. So x minus 8 plus 4 is my g of x, and then minus h of x was 1/2, x minus 3 squared minus 4 dx. Let me just double check that I have enough parentheses. So I've got this set of parentheses. I've got this set, this set, this set. Okay, I'm good. All right, so this is how we can set up the integrals. To solve this by hand, you would have to expand this. You'd have to do a bunch of algebra. But for these types of problems, we generally don't have you do that. We just have you use a calculator to solve. And you do need to know how to use a calculator to solve integrals, obviously, as well. So make sure you can do that.